Hello, everyone, and thank you for joining me today. My name is Dylan, and this presentation explores the exciting world of bioprinting with a special focus on its potential to regenerate damaged or diseased eyes. This topic is deeply personal to me. Having undergone eye surgery myself, I was once at risk of losing my vision completely. That experience pushed me to learn more about how modern science is pushing the boundaries of what's possible in medicine, and I discovered just how promising bioprinting is for the future. So let's dive into what this technology is and how it works and how it might one day restore eyesight. So the purpose of this presentation is to investigate bioprinting as a cutting-edge solution for eye repair and eye regeneration. Our learning objective today is to understand the basic science behind bioprinting, explore how it relates to cells, tissues, and organs, especially the eye, and evaluate its current capabilities and limitations. We'll also look at some promising research and developments and discuss whether full eye regeneration could realistically happen in our lifetime. I want you to leave here not just understanding the concept, but also appreciating its potential to change lives, including the lives of those like me who have faced the possibility of blindness. So let's start by tackling a big question. What is bioprinting? Bioprinting is a form of 3D printing that uses living cells, growth factors, and biomaterials instead of plastics or metals. Uh, these biological components are layered together to build structures that mimic natural tissue, sometimes even full organs. The goal is to create functional, transplantable body parts using a patient's own cells, which would reduce the risk of rejection and improve healing. For eye regeneration, this technology could be used to print delicate layers of the retinal tissue and corneal structures that are used critically for vision. What makes this different from traditional tissue engineering is the precision. Bioprinters can build tissue layer by layer at a microscale to replicate the complexity of natural anatomy. Think of it like printing a custom-made replicate or replacement part for the body, but one made of cells, not plastic or metal. This is the foundation of how bioprinting could one day restore sight. So, how does it work? The bioprinting process begins with pre-processing, where doctors use detailed scans like MRIs or CAT scans to create a digital blueprint of tissues. Next is bioprinting, where bio ink is dispensed layer by layer to form the shape of tissues. Finally, during post-processing, the printed structure either matures inside a special machine called a bioreactor or is implanted directly into the body to finish developing. Precision is key here, especially when working with something as delicate as an eye. While full eye structures are still a challenge, early progress has been already made in the bioprinting corneal and retinal tissues. So that's promising. So this definitely wouldn't be complete without a little background on this optical organ that we're talking about. The eye is a super complex organ composed of many different types of specialized cells. The cornea, which is the transparent outer layer of the retina, which processes light signals, are two of the most delicate and essential parts of the eye. In my own case, I had eye surgery where the risk of permanent eye vision was very real. So I became curious of whether bioprinting could help people like me in the future, or just in case somebody did take the surgery and it went south. By layering living cells into organized structures, researchers have started replicating parts of the eye that were once thought impossible to repair. Personalized lab-grown tissues may eventually restore sight or even prevent blindness entirely. Honestly, bioprinting is a game changer in the regenerative medicine field. For eye health specifically, researchers are already printing corneal tissue, which could one day help people who suffer from injury, infection, or degenerative diseases regain their sight. Because the tissue is printed using the patient's own cells or compatible bioinks, the risk of rejection is lower, but not impossible. Beyond eye care, bioprinting is being explored for skin grafts, bone patches, and cartilage repairs. The ability to build customized living tissues on demand could reduce wait lists, replace donor shortages, and improve the quality of life for thousands, if not millions, of patients. Despite the promises, there are still major challenges in terms of eye regeneration. Replacing the full function of the retina or optic nerve is incredibly complex, hence the complexity visual that I put in the slides. These parts of the eye rely on delicate structures and connections to the brain, and recreating that artificially is still beyond our current capacity. Even simpler tissues like corneas face problems like cell survival during the printing process and keeping the tissue alive afterwards, which requires blood vessels or vascularization, something researchers are still working to perfect. On top of that, there are regulatory ethical barriers, and access to equipment and expertise is limited due to high costs. Honestly, this research wouldn't be complete without a little look into stem cells as well. So, stem cells are essentially blank slates that can turn into almost any type of specialized cell, which makes them incredibly valuable for regenerating tissues. In bioprinting, for example, researchers often use these three main types: embryonic stem cells, which are very versatile but come with ethical concerns; induced pluripotent stem cells, or iPSCs, which are reprogrammed adult cells that don't have the same ethical barriers; and adult stem cells, which are more limited in what they can become but are still very useful. For eye regeneration, though, stem cells are being tested to rebuild structures like the retina, which is essential for vision. They are also used to recreate transparent layers of the cornea and even the nerve cells in the optic pathway. This is one of the most promising areas of the bioprinting research when it comes to restoring sight. So I mentioned it before, but what is bioink and how is it used? Bioink is what 3D bioprinting with living cell, what makes 3D printing with biocells possible. Think of it like the ink of a normal printer, but made of like a gel-like material that contains live cells and other substances to support them. These materials can be natural, like collagen, gelatin, and or synthetic, depending on the tissue being printed. For eyes, especially structures like the cornea, bioink needs to be incredibly precise, transparent, while still supporting the cell's health and function. It's like a fine balance. The bioink has to keep the printed shape intact while allowing cells to grow and behave like real tissue. So, where is research at now? They are making exciting progress in bioprinting by producing various parts of the eye. For instance, scientists have successfully bioprinted retinal cells like photoreceptors and retinal ganglion cells, which are crucial for restoring vision loss and from diseases like glaucoma, which my father has, or macular degeneration. At Newcastle University, a team created a 3D printed human cornea using bioink made of human corneal cells mixed with anglionate and collagen. The printed structure maintained transparency and viability, showing the promise for future transplants. Other labs are developing things like retinal tissue layers using induced pluripotent stem cells, which could eventually allow for personalized implants that restore light sensitivity and neural pathways to the brain. While these are still largely in the experimental phase, the results have been consistent and encouraging, especially in animal models. So let's take a quick look into the future. The future of bioprinting is incredibly promising. Scientists are working towards printing entire functional retinas and even optic nerves to help restore visual function. This could revolutionize treatment for patients with degenerative eye diseases or trauma-related vision loss. AI-guided bioprinters. Gotta talk about AI. It's 2025. These are expected to increase precision in layering complex tissues like retina, which is multiple delicate layers of specialized cells. Alongside this, stem cell technology is advancing. This may allow patients to receive grafts made from their own reprogrammed cells, reducing the risk of rejection from the body. There are also discussions about bioprinting in space, where microgravity can help the tissues grow more naturally without collapsing under their own weight. This could give us deeper insights into complex organ printing.
This topic hits close to home for me. After undergoing eye surgery and facing the real possibility of permanent blindness, I started to think more deeply about the future of medical technology, especially bioprinting. The idea that one day a person might regain their sight through a bioprinted retina or cornea is more than science fiction. It's a real emerging possibility. Bioprinting could be life-changing for people like me who've stared down the fear of losing their vision. Beyond the personal, this technology could empower millions of patients who currently have no viable treatment options. Whether it's regenerating a damaged cornea or building an entire ocular system from stem cells, the applications for bioprinting are deeply human and deeply hopeful. So, to wrap it all up, bioprinting is one of those revolutionary technologies that feels like science fiction. But it's quickly becoming part of our real world toolkit in regenerative medicine. When it comes to eyes, we're seeing remarkable strides in bioprinting retinal tissues, corneal structures, and even exploring how to regenerate entire visual systems. While there are still some big challenges like complex vascularization and regulatory hurdles, the pace of innovation is speeding up, especially with things like AI, stem cell technology, and advancing printing techniques. As someone who's faced the fear of losing their vision, I truly believe that this technology offers a new kind of hope, not just for the future, but for people living with vision loss today. That being said, here are some sources that I had throughout this presentation. All of them are peer-reviewed or published by reputable academic publishers, at least as far as I can tell. And they provide a solid foundation for everything we covered about bioprinting and the eye regeneration. I made sure to cross-reference some of this information from both the textbook and cutting-edge research articles, so everything I share was rooted in science. Thank you, and I appreciate your time.